everyone, my name is Zheng. Today, I'm going to introduce you our antenna design process for in-band full-duplex and MIMO systems. For both IBFD and MIMO systems, if the beam directions of multiple ports are inconsistent, the correlative communication performance would be significantly reduced. Therefore, it is a challenge for these systems to achieve pattern consistency while maintaining adequate isolation. This picture shows the design process of our IBFD antenna. Firstly, in reference antenna 1, a single mechanical probe fits a cross-shaped dielectric resonator, and as we can see from its S parameter, there are 3 modes, named Mode 1, Mode 2, and Mode 3. They are actually T2.1, T3.1, and probe-loaded mode, respectively. In antenna 2, a strip is loaded on the probe, and as the strip length increases, Mode 2 and 3 moves closer to each other and finally merge into one mode. Antenna 3 is extended to 2 ports, and there are 2 transmission nodes in its S parameter. The mechanism behind the 2 nodes is shown in the 2 graphs here. Node 1 is formed by the superposition of mode 2 and 3, and node 2 is formed by the superposition of mode 2 and 4. They both lead to a quasi-T1.1 mode. In order to verify this mechanism, we checked the radiation patterns at node 1. As we can see, the radiation patterns are exactly broadside. However, because of the strong E vector along the y-axis, this antenna suffers from a large cross polarization. So, on the basis of antenna 3, a substrate-integrated open cavity formed by metal vials is presented in antenna 4. As we can see, this process has minor impact on its S parameter, but it can significantly suppress the E vector along y-axis and reduce the cross polarization. After this, we dig a square hole in the center of the DR and get the proposed antenna. This action leads to another 4 dB improvement in isolation level. For validation, a prototype of the proposed antenna was fabricated and measured. It has 1.6 GHz bandwidth, 25 dB isolation, and stable radiation patterns. Finally, we made a comparison with other related IBFD designs. As shown in this table, our work achieves relatively low cross-polarization, high gain, and wide bandwidth while maintaining stable radiation patterns. Then, this is section 2 of our article. We designed a 2x2 MIMO with the antenna element we designed in section 1. The distance between them is half lambda. Actually, this method can be easily applied to design 2x N MIMO. For validation, a prototype of the 2x3 MIMO was fabricated and measured. It has a bandwidth of 1.4 GHz and isolation of over 20 dB. Besides, the radiation patterns of every port are stable. Finally, we made a comparison with other related MIMO designs. As shown in this table, our design has stable radiation patterns with a relatively small space and is extendable to larger areas. Both the antenna element and MIMO are highly potential to be applied in IBFD systems. Thank you for your time.